Okay, here is our notes. The last one for this section, it's linear inequalities. And it says, what is that? It's similar to a linear equation, but it has an inequality symbol. And remember inequality symbols? This is when we have this or that, less than or greater than, or it has the line underneath it, which would be an equal. So it would be less than or equal to, or greater than or equal to. So there's the symbols that these will have. And a solution to this will be all of the pairs x and y that make the inequality true for the situation. So to give you an example of what this means is, here's an example. It says that if we have this equation here, notice it has the less than symbol. So it's like I'll go to each one of these, I'm going to write it so that I have this 2x minus 3y is less than 15. What I'm going to do is remember that the 2 here is the x coordinate and the 5 is the y. So I'm going to substitute them into my problems here. I'm going to put these in parentheses because that's what I'm going to replace in each one of these. So that the first one I'll have 2, and then what I'm placing in the x is a 2. Then I have a minus 3, and then the y value is going to be placed in as a 5, and then I'm going to test to see if it is actually less than 15. So if I actually do this mathematics, 2 times 2 is 4, and 3 times 5 is 15. So 4 minus 15 is a negative 11. So I need to ask myself, is negative 11 less than 15? And yes, it is. So that is a solution. That's a true statement. If I go to the second one, this is still my x and this is my y, but I'm going to plug it in just like I did before, so that when I replace it, I'll have this writings here. Let me write it down first, and you can copy it. It has 2 times a negative 1 minus 3 times a negative 7, sorry. And I'm going to go ahead and put that in my calculator, but you can do the same. 2 times negative 1 minus 3 times negative 7. I put it all there and push enter, and it tells me that it is 19. So this is saying, is 19 less than 15? And that is a false statement. That is not true. Okay, if I go to the third one, do the same scenario. 2 parentheses, minus 3 parentheses less than 15. Remember, the 3 is the x and the y is a negative 4. So if I plug this in, and enter, this shows I have 18 less than 15, which that is a false statement as well. So that means that is not an answer. That's false. I'll plug in the last one. It has zeros. 0 times 2 is 0, and 0 times 3 is 0. So that means this left side is a 0. So I have 0 less than 15. That is true. So for this equation here, I have 2 answers, and they are the true ones for sure, at least. I know that 2, 5 is an answer, as well as 0, 0. So this is showing you that I actually have 2 answers that are listed here that are possible solutions. In a graphical sense, right down here, it shows that we can find our answers by graphing it. And one of the steps is we got to have it in slope-intercept form, which that was the y equals mx plus b. But I'll just have an inequality here instead of an equal sign. That equal sign, that inequality will have 2 options here. That if it does not have the line underneath it, if it has a line underneath it like this, the less than or equal to or the greater than or equal to means it'll have a solid line. Just be a solid straight line. If it does not contain the equals, then that means it's not equal to, and the way we show it is by having a dashed line or holes on the line, so it is not showing that everything on that line is not an answer. The third step is that we got to test a point, and usually we'll plug in 0, 0, just like we did right here. Plugged in 0, 0 to see if that is a true or a false statement for that particular equation. there's 3 steps we're going to do on these problems. And one thing to really notice, it says all the points within the shaded region represent the solutions. So I want to add on here, we're always going to shade the true side. Let me put that here. Oops, sorry. Shade the true side of our equation, of our graph. Alright, if we look at our equations, on the first one, we got to check see if it's written in slope-intercept form, and the y is by itself, so it is. I'm going to identify the slope as 1/3, and then my y-intercept is 0, -5. So this is where I start my graph. And then from here, remember, this is the rise over the run. So I'm going to go up 1 and 1, 2, 3. 1, 1, 2, 3. 3, okay. And I need to draw my line, but I have to check my symbol first. And this symbol is the greater than symbol. Greater than symbol means I'm going to draw a dashed line. Alright, there's my ruler. This has to be a dashed line. Okay, and then I need to test a point, and this is where I was testing the origin of 0, 0. So if I plug in 0 into these parts, I'm going to rewrite my equation real quick. That means I'm going to place a 0 for my y and a 0 for my x. So I'm testing 0, 0. Well, when I do this, I have this setup here. 1/3 times 0 is just 0. So the question is 0 greater than -5. That is a true statement. So that means that point right there is true. That means everything above is true, and false is below the line. This is the false side. So I have a true side and a false side. And then we said we're always going to shade the true side. So you can either fill this in solid, or you can just draw the lines like I'm doing here to represent the top containing all the solution points. That means any point up here, I can pick any point and put dots all over the place. Any of these points will give me a true answer for this equation. Anything below the line down here will give me a false answer. They will not work for the line. The graph is your answer, by the way. Alright, number 2. On this one, it is written in the correct form, so I'm going to identify the slope as -2. I'm going to put that over 1 because I have to have it as a fraction. And then the y-intercept will be -1. If I plot 0, -1, and then I go down 2 and write 1 on this particular graph, I look at my symbol, and now it has the line underneath it. And when I look at my notes, the line underneath it means I have a solid line that I'm going to draw. Okay. And then I need to test a point. I'm going to test the origin. It's not on my line, so I can test it. And I'm going to plug 0 in for the x and the y, so it means I have 0 is less than or equal to -2 times 0 minus 1. This simplifies to 0 is less than or equal to -1, which that's false. Okay, 0 is not smaller than -1. So this is a false statement. That means everything on the right side of this line is false. True is on the left side, and we always shade the true side, so that means I'm shading to the left. Okay. Alright, number 3 is not written in slope-intercept form, so I have to do some math for this first. I want to subtract the 5x, and that means a -2y drops down, and I have a 12 minus 5x. I need to divide by -2, so that I have y is greater than 12 divided by -2 is a 6. And then negative 5 divided by negative 2 is a positive 5 over 2x. Now this is not written in the proper form, but it is okay. The slope, remember, is always your x. So that means my slope is 5 over 2. And then the constant is always going to be your y-intercept, so that's 0, negative 6. I'm going to plot the point negative 6 and go up 5 and over 2. 1, 2. There we go. 1, 2, 3, 4, 5, 1, 2. Alright, now when I draw my line, check your symbol. My symbol there is the greater than symbol. Greater than symbol means I have a dashed line. Okay. Alright, then I gotta test a point, and as long as my line is not going through 0, 0, I can test it. And I'm gonna plug it into my modified equation, not do the original. If I plug it into my modified one, I'm out of room here, so I'm gonna squeeze it on the side. Remember, the y is gonna go to a 0, and the x is also going to a 0. But this second half, when x goes to 0, it just cancels out, and I have 0 is greater than negative 6. And that is a true statement. So that point right there is true. Bottom is false, and we always shade which side? We always shade the true side. Let's shade the top half. Okay, if I look at number 4, it is not written in the correct form, so here we go. I'm going to rewrite it this time so I have a little more room. I'm going to subtract the 1x. The negative 4y drops down. I'm going to divide by negative 4 this time. So I have y is less than negative 2 plus 1/4 x. My slope is always the x, which is the 1/4, and my intercept is 0, negative 2. If I plot the negative 2, I'm going to go up 1 and right 4. And now check your symbol. Will that be solid or dashed? Well, because it's just the less than symbol, this is dashed. There we go. Now, testing 0, 0, I'm going to do it into my modified equation. So I'll have 0 is less than negative 2 plus 1/4 times 0, which that just cancels out. The question is 0 less than negative 2? And that's a false statement. That means down below is true. And I need to shade the true side. Okay, number 5. I want to rewrite my equation with coefficients so that I don't mess up. I'm going to subtract the 1x, and the negative 1y drops down with my symbol. And I just realized I messed up on these problems. Oh shoot, I'll do it on this one. I just realized that. Okay, I'm going to divide by negative 1, and I'll go back here in just a second and see if I can edit this, because it'll be my shading will be wrong. When I divide by negative, I forgot to remind everybody, as well as myself, that when I divide by the negative, it has to flip that symbol. And I just remembered that. So that means that y will actually be less than or equal to negative 8 plus 1x. I just realized that. So I'll see if I can fix the which ones? It had to be number 3 and 4. I have to fix those. Okay. The slope is a 1. I'm going to make that a fraction of 1 over 1. And then the y-intercept is 0, negative 8. Oh, whoops, almost drew my line. If I look at my symbol, notice it has the equals underneath it, so that means this is going to be a solid line. Okay. And then I'm going to test my point of 0, 0. I'm going to go into that equation, so I'll have 0 is less than or equal to negative 8 plus 1 times 0. So the question is 0 less than or equal to negative 8? And that's false. So that means this little spot down here is true, and we will shade the true side. Okay, so up here, what that means is right here, this symbol should have been flipped. So here it should have been flipped going the other way, and it says 0 less than negative 6. That is actually a false statement. So that means this is actually a false statement, and here's the true side. So that means the shading that I did over here, and since I did this with a marker, I have to white this sucker out, and that means the correct answer is on the bottom side of this. Okay. The line is the same, it's just where the shading is. So on the second one, right here, when I divided by the negative 4, that means this symbol flips right there, and that means this true-false thing flips. So the question is 0 greater than negative 2. That's true. So that means this is actually a true statement, and this is the false. These lines right here should not be there. Okay, oops, that one won't go away. And then my actual answer should be right here on top. Okay, I apologize for that. I forgot the flipping of the symbol. Okay, flip symbol. That's very important. You see how I messed up. Alright, so 5 is correct in what we have listed there. Alright, let me go on to 6. If I rewrite this, I apologize for that. This is 3x plus 2y is less than 0. I'm going to subtract the 3x. And that gives me 2y is less than 0 minus 3x. And divide by 2. Since that's a positive, I don't touch the symbol. So I'll have 0 divided by 2 is just 0. So that means my slope will be negative 3 over 2, and my intercept is 0, 0. So this one is starting at the origin, and it's going down 3 and over 2. Like that. And then the symbol is just the less than symbol, so I'm going to have a dashed line that I'm drawing. And now, because this is at the origin, it's going through the origin, I can't use 0, 0 as my test point, so I'm going to use 1, 1. If I plug in a 1 for the y, a 0, and then I have a minus 3 over 2 times 1. Well, let's see what that is. 0 minus 3 divided by 2 times 1. That simplifies to negative 1.5. So, is 0 less than negative 1.5? That's false. Means this is the true side. And we shade the true side of our equation. Okay. Now for the weird ones, 7 and 8. Notice on 7 and 8, they only have one of the letters. So, we have to go straight into graphing. Now basically, they're telling you the y value is -4. They don't tell you the x, so that means it's a 0 on this one. On 8, they tell you the x value is 7. They don't tell you the y, so that's a 0. This is how I'm getting my points. If I take the first one and plot 0, -4, I'm right there on my graph. Now, the x value was 0. It's on the y-axis, which is vertical. I have to draw a line opposite of the axis that it is sitting on. So instead of a vertical line, I'm going to draw a horizontal line. So it's got to match the x-axis. It's got to be parallel to it. Now, I look at my symbol, and I notice it has the equal sign, so that means it is a solid line here. Okay. If I do the same thing for number 8, this is at 7, 0, which means it's up here. Oh, no, I messed up again. Okay, 7, 0 is out here. And notice I placed it on the horizontal axis. Therefore, I draw the opposite, which means it is vertical. And I look at my symbol, it does not have the equal, so I'm going to make this one a dashed line. Okay, so I have my lines drawn. Now, I still have to deal with the shading. So I'm going to test 0, 0 on both of these because they do not go through that point. So if I do the test on number 7, 0 is less than or equal to -4. That's false. That means this side is true. And I shade the true side. On 8, I plug in 0 is greater than 7. That's false. So this side is the true side, so I shade that little bitty piece on the end. And that's how you do those special lines. Alright, remember, don't mess up like I did right here on 3 and 4. Remember, when you divide by a negative, your symbol flips. And it changes where you shade on your graph.